All right, welcome back everybody. We are now moving into project 13 of our Arduino starter projects, and this one is the Touchy-Feely Lamp. In this particular project, we aren't going to be looking at any new components on the board. Instead, we are going to be looking at a new library that allows us to use pretty much raw wires to detect the capacitive value of a piece of material, right? Whether it's a piece of metal or a piece of plastic or your finger, or whatever it may be. We're not looking at any new hardware that you haven't seen before, just a new library. So let's go ahead and take a look at the code, which is pretty straightforward, nothing too terribly complex that you haven't seen before. And it'll make a lot of sense to you, and then we'll talk about some of the specifics, and then obviously in the next video we'll go through the board walkthrough. So right off the bat, we have our startup and our loop. We've seen these, right? We know these. The first thing is the include of the capacitive sensor header, and that therefore brings in the capacitive sensor library for us. And we have a variable that we just call cap sensor, which is of type capacitive sensor. And you'll notice in the constructor, we pass in two parameters, 4 and 2. And these align to pins on the board. So we have 4, and this first parameter to the constructor, in our case 4, is the 4 pin on our Arduino board. And it is the send or transmit pin to send the signal out to measure against for capacitance. When we look at this 4 pin, it's really kind of our base. Nothing's going to be touching this wire. So the difference between the signal on 4 and the signal on 2, which is our receive, the difference between these two is going to give us a capacitive value. And we're going to look at this in a second. And based off that value, the difference between these two pins is going to determine whether or not we light up the red LED or not. And so we are going to set a threshold of 1,000, right? That's where we want to look at what's the variation of capacitance between these two. If it's a threshold of 1,000, we want to turn on the red light, right? Or maybe we look at it even less than that. We can play around with this, and that's just going to make it more sensitive, right? So the smaller the number, the less capacitance is on the material that you're touching, right? So plastic's going to give you very low capacitance. Metal probably give you very high capacitance. And so again, if you play with this threshold, you just get more or less sensitivity to the capacitance of the material you'll be touching. And we'll look at this more when we walk through the board. Other than that, we've got our LED pin, in this case pin 12, it's going to be an output pin. And then we have our baud rate constant. We're going to still call serial begin, even though we're not going to call any of the serial print line functions. Same reason, it's just no need. It makes the code more complicated than it needs to be, and we've talked about that before. So here in the setup, pretty straightforward. First, we're going to set up our LED pin, in this case pin 12, and we're going to set it up as an output pin. And then we're going to set up our serial to communicate with our computer at a baud rate of 9600. And again, if you want to start putting in the print statements, feel free to. I always initialize the serial ports for anybody who wants to take a look at that. Just makes putting the print statements in easier if you want to later on. But going into the loop, the first thing that we're going to take a look at is our capacitive sensor, cap sensor variable. We're going to call the method capacitive sensor on that. And you'll notice the lowercase capacitive rather than the uppercase for the constructor. So this method, what we are saying is give me 30 samples. And keep in mind that this call to get the 30 samples is blocking. If you're not familiar with what anything about threading or asynchronous software development, don't worry too terribly much about it right now, but just realize that this is a blocking call, which means there's no other code being executed until this function returns a sensor value. And that sensor value is based off the 30 samples that the library is going to go out and sample the difference of capacitance between pin 4 and pin 2, and it will get 30 samples every time we run through this loop. Now, once we get that value, what we're going to do is we're going to say is the value that we got back, is it higher than our threshold, right? And we have a threshold of 1,000. If it's higher than that threshold, we're going to simply turn the red LED on, right? We're going to write to our LED pin high. And if it's below or even equal to our threshold, we're going to turn the red LED off, and right, go to low. That's simple. You've seen this plenty of times before, and it's just based off the 30 samples that the capacitive sensor library gives us. That's pretty much it. The only other thing, they have a delay for 10 milliseconds in the book, and this, really is probably something within the capacitive sensor library. Just give it time to clean up anything that it may need to, might have memory to clean up. So next time we come back in, we're not leaking memory or having anything stomp on one another if we are dealing with a very fast cycle here. So just delaying for 10 milliseconds. But that's about it. As you can see, nothing new really here. It's just relying on the library, the capacitive sensor library, to tell us what the capacitive difference is between the 4-pin and the 2-pin. And when we look at the board later, you'll see that there's no new hardware on that either. So pretty straightforward once you understand the capacitive sensor library. Now, looking at this, right, this capacitive sensor library, it provides the functionality to distinguish the capacitive difference between the 2 pins. It's a convenience function. The 30 samples, we didn't have to write hardly any code, one line. Give it the value of 30, we get 30 samples on the difference between the capacitance, and we're off to the races, right? So really helped us out quite a bit on that, and that's really what the library is for. Next, when we look at the actual variable, we spoke about this taking 2 arguments, right? It takes the 4-pin and the 2-pin. The first argument is the send to transmit. It sends a signal to measure the capacitance against. If it's going to measure against something, there has to be a known baseline, right? And so that's what this the 4-pin, and you'll see it later on in the board where the wire coming out from the 4-pin doesn't touch anything other than the resistor. And here again, the second argument is the pin that's going to receive information back from the external world, right? So we have this raw naked wire, there's no shielding on it. So we're going to touch metal to metal, get back a high capacitance, touch metal to plastic, get back a low capacitance, something along those lines. But again, we're just using a wire to touch real physical world objects and determining how much capacitance naturally the material that we're touching has, right? And so don't need another piece of hardware, just this library to help us out, and that's pretty much about it. So as you saw, the code was pretty straightforward. Nothing too terribly new from a technology perspective, no hardware, just kind of understanding that we're going to be touching real world objects and getting that information back into our board. So we will see you in the next video as we actually do this board walkthrough and see what some of our common household items have for capacitance. We will see you in the next video. Take care, everybody.